super short video, just needed a spare mouse for testing purposes. So yeah, this looks really yellowed, and you know what it is, but it's not that bad actually. A bit of H2O2, that'll come up really clean. The cable's good, but there's supposed to be a fault with this, so yeah, let's go test this. It's switchable, Atari or Amiga. So yeah, so it's next to the nice optical mouse here from Alice and Chalice. There'll be a video link top right to that. Switch to Amiga on the right hand side here, and we're on the 1084S that I fixed the yoke on recently, and it doesn't move. It looks like it kind of wobbles a bit. Yeah, the right button works and the left button works because it can move the bar marginally. So yeah, both axes are not working. So that could mean two broken connections in here, one for the horizontal, one for the vertical, or it could just be some dirt or something. So let's have a look inside this. Just a quick message from this video's sponsor, and that's you. Thanks ever so much for supporting on Patreon and Coffee. I can't thank you enough. Let's pull the ball out as well, if we can. That's it. Yeah, so the ball looks pretty good. Those can disintegrate over time in some mice. So I mean, it looks pretty clean in there, but yeah, we'll start by just giving it a bit of a blow, like that. If you get a bit of contamination in there, hairs or dirt, that can be a problem. And what we'll do next is test it like this, exposed actually, and just rotate these, see if you get any of the desired response. It's going to be a cable problem though. The cable is bound pretty tightly here. So I suspect, yeah, it's going to be probably this, pulling it up, or here. Yeah, so test it exposed like that, not doing anything. So let's just get these two screws out that hold the board in. First we'll test the switch, inspecting the solder points there. Looks alright from a distance, I think. Multimeter switched onto continuity test. Beep. The switch, let's test this, hang on, where's it gone there? The switch first, so the switch is here. So you've got two rows of three contacts here, so we'll just test from one side here, hang on. So from the middle to that side and that side, nothing. Is it going to be a switch? I think it's the switch. I think the switch is balked, because it's not doing anything, is it? So let's just pull the little nubbin off the end there, get some contact cleaner into that switch there, so try and press it like into the base there of it, and do a little bit of switch like that. Let's see what that's like. And I did just do this over there, switched it off and on a few times. I didn't spray contact cleaner in there. So from the middle, yeah, we've got a join there, look. And if we test from the middle to the right hand pin, nothing. Middle to the right hand pin there, nothing. Switch it over. I'll be very pleasantly surprised if that fixes it. Got a join there from the middle to the right hand side. Got a join. And we don't have a join on the left one, so actually that might be it. Right, that wasn't the issue. What is the issue with it? It's suffered from Dropius Mouseus. Yeah, what happens is, you see these little stand-up things here. Yeah, you've got red ones and blue ones. Yeah, the optical. One's an optical, like I think a photodiode or a phototransistor. Photodiode, actually, two connections. And the other one's an emitter. Yeah, they work with infrared. So an infrared beam shines through the little wheel, and as it spins around there, it makes and breaks the beam on each side. And because there's a timing difference between the make and the break, it can determine which way you're rotating it. You know, if you go that way, this one will break before that one, and when you suddenly start going that way, this one will break before that one, etc. And all I've just done here is just push these slightly nearer towards each other on that side. And if I move that wheel, you can now see we can move up and down. Yeah, I've seen this on Commodore mice before as well, actually, you know, official ones. So up and down's working, left and right isn't. So it could still be the cable, and I did just experiment with the cable, bending it marginally, but anyways, just push them slightly nearer, and again, slightly nearer. Yeah, that side is still not working, so is it the cable? Let's experiment with the cable a little bit here. Yeah, it's not the cable, I don't think. Right, let's just go back and check the cable. And when I was talking about it being dropped there, my point is with like significant impacts and stuff, these things could just move just a tiny little bit marginally, and it can also be the life of these, you know, they emit slightly less, etc. But nevertheless, I've seen it quite a lot in the past. So the cable, it's a nice easy one, isn't it, this, because you've got connections here, and you can measure from there easily, and you just need a fine probe to jab in here, and we should have a connection on all the ones where there's a wire. I'll just simply do that. Let's just start with one of these here and see if we get a connection. Let's just flip that over. Do it from the underside, it's easier because we've got access to all 8 connections there. Yeah, so anyway, you get the idea. Yeah, that's one. Right, so we have connections on all 8. So it's going to be one of these emitter pairs here, isn't it, or the IC. Yeah, so the next thing here is camera on the phone. If you look at these LEDs, can you see that looks nice and purple? Yeah, that one's emitting, and the one there, can you see there's a purple dot in the middle, that one's emitting. And scrolling over to the other side, look at that one. That one's a bit dim, that one's nice and bright. So my guess is it's that one there. I think before I try bending one of those marginally, because I don't think they're pointing in the right direction towards each other, a bit like the other one was, I'm just going to get a wee bit of IPA. And these are painted on top actually, it's like there's a mark on top of it. And I'm just going to get the IPA like that, just trying it onto the surface of each of these, because if you get some dirt or dust or something that settles on the inside of those, you know, the surface of those sensors, it can make a difference. Right, and I'm going to try that again to see if that's made any difference at all. Yeah, and the one on this side actually I think is dead. That's what it is. There's just nothing, no emission out of that. So I'm just going to desolder that, pull it out of circuit. Just go see if I've got anything else I can use to replace that. And this is the problem, is trying to find these diodes. But you know what? It is just like an infrared diode. That's what it is. It's getting the right wavelength, but as long as you get the right ballpark, the sensor on the other side should get influenced by the signal. So let's just try and heat and desolder that. Single-sided boards, so you don't need very much heat or a very powerful iron to remove things from something like this. Be careful not to melt the plastic wheel there that's right next to the point you're soldering. So just carefully pull it out, and we can now test that out of circuit actually. Just stick it on there. It's, you know, it's just an LED effectively of the infrared variety. So we've got a reading that way, 1.025. Let's read it the other way. It may have shorted. I mean, I could smell like a plasticky. No, it's not. So the LED, you know, in terms of it being a diode, it still works, but it's obviously not emitting very strongly, is it? So I think the next thing I would do is just look at the circuit here and just see how it's wired. Yeah, so it's going via that resistor there. So in theory, you could, you know, change the size of that resistor there, reduce that a little bit, and then both of these will get a little bit more voltage. Yeah, I'm thinking something crazy like this. This is an infrared diode. This is giant though. This is going to light up the whole mouse and confuse every sensor in there. But you know, I don't know. And this is, I think it said 940 is the frequency for this. You know, the part of the spectrum it's on. Right. So just bodging that LED into the connections there. Can you see that? Yeah. Hopefully you can. Pinky purple when you get straight on there. Yeah, so let's try and bodge it in there. So conveniently, the way I had those legs bent, you know, it was like facing this way like that, yeah? When you flip the board over, that's the way it's going to face, so it's going to be in there, facing this way. But before we attempt to mount it, and the intensity looks just right. Yeah, I'm going to cut a piece of this to size, let's just do that. Yeah, heat shrink is so useful for so many things. You'll have seen me use heat shrink to fix so many crazy things, it's ridiculous. It's useful for securing things, but masking light off in this case. And what I'm going to do is get it right on the back there, shrink it so that it kind of comes round on the front to a point. And And this is the thing, I see people on these forums, you know, help, I need to get a photo component, you know, photo diode for this mouse, and they're no longer available, and oh, what am I going to do? And it's like, well, just use another LED. A little bit of hackery and bodgery. You'll be amazed at what you can achieve. And these are always going to be in stock. You know, there's so many people selling these infrared LEDs. And of course you could go with something smaller. You could go with a 3mm LED here, then you'd have to do a lot less work in terms of heat shrinking and faffing around probably. And you can get SMD ones as well. You could get really creative and have a little PCB design to mount a single SMD LED that has some solder points for some wires. And this is the thing now, see, look, if we shrink here, the front, it's going to make a nice little point on the front of it to try and help diffuse the light, so that hopefully this LED won't, you know, like illuminate the whole inside of the mouse with scattered IR. I think that's going to do the job, you know, but we may just need to cover further there, because the heat shrink on its own at the front might not be, you know, it might not be focused enough to a point. This is the thing. But that's where something like a black permanent marker comes in. You just use the black permanent marker on the inside, yeah, circle the front of it, so you've got a tiny little gap in the middle, and I guarantee that will work. These things are not as magical as you may think. You just need light to go through the slot and come out the other end. Right, that'll do I think, so we'll just give it one more blast on the front, try and shrink that a little bit more. Yeah, that's not bad, there's my bodgy thing, so we need to get it through the holes. Let's just do it straight down a little bit, and then we need to kind of bend it back over this way, don't we? Like this, and over like that. So yeah, it's going to be sitting on top of that mouse there. And it's like a little, it's like a cannon, isn't it? It's like a giant beam here. And this is the thing, I might need to relocate that resistor actually, because if that resistor wasn't in the way, this would be a lot easier. I mean, in theory, there might be enough space to mount the resistor on the underside in here. Yeah, if you look at the standoffs here, there might just be enough. Hang on, the component just shot off onto my leg there. Oh, it's a screw. Yeah, I lost a screw for a minute. Yeah, that resistor, it may just fit under here. Let's just relocate that resistor actually, let's just try that. It just means that LED is going to fit lower down and be more in line with where it needs to be, I think. Yeah, hopefully there's going to be enough clearance for that resistor. It's cutting it fine. I mean, what I could do is just swap it with an SMD one. And just a little wire, because then it will be super flat and low profile, won't it? So yeah, let's just see if we can do it this way first. Single-sided, so don't heat for crazy time with crazy heat, whatever you do. Let's just test it out now to see if there's enough clearance in there. Get it back in. Yeah, there is. It's fitting flat and flush without an issue, so that resistor's fine on the underside there. Yeah, so place your bets. Do you think this is going to work or not? Yeah, I think not until it's had a bit of adjustment. Right, let's just solder it on. I think we should change the channel name to Gadget Bodger Stuff. Or Bodging with Gadget. Or even Bodget. Right, let's just trim that off. Yeah, maybe don't trim them down completely until you know it's in the right position. But you can see it's a bit high up here. It may need just tilting like that a little bit and pressing that way, and we may need to do something with the end, let's say colour it in or something. Let's go try that. Right, we're all plugged in, our bodge is ready, and I can't see where the cursor is, and let's wheel it. Oh, look at that. Look at that. Would you look at that? It works now. There we go. I have fixed a mouse with a bodge, and my bodge was successful. It's got this linearity issue sometimes you can have, and this is where the sensors just need a slight tweak. I'm just going to move the other one away a little bit. Yeah, bend them out in and outwards There we go, perfect now. I'll show you what I just adjusted to make that more linear when it goes to the right. So what was happening there, when I moved left it went really smoothly. When I went right it moved a bit, but then struggled a bit, moved a bit, struggled a bit. Bent this red one out a little bit. Yeah, and this is the thing, this is what we did with this one. This is why it wasn't moving in that axis, but now both axes are perfect, absolutely perfect. So yeah, we'll just reassemble this. I'll just clean off the bit of flux on the underside there, but a successful bodge. And it's important to note that the same thing applies with the diode bit. You know, well, they're both diodes. One's you know, detects infrared though. Yeah. So you could just get the same sort of component, like say, mount it the same way. You might have to relocate these on the underside, but then problem solved. Yeah. So yeah. Anyway, at least we know that one I'm writing on didn't 940 nanometers, I think it was. So that's probably a good ballpark. Most of them are probably like that. So yeah, just get yourself some 940 nanometer infrared LEDs, because they're useful to fix these mice. Might need to do this on my Commodore mount, the C64 one. I forget the actual part number. Is it 1531 or something weird like that? I don't know. It's got a weird part number. But yeah, the C64 mouse, the LEDs on that were breaking. You know, they break down a bit over time. They stop emitting as brightly as they should do. And the receiver parts are probably more likely to be resilient and last. It's the emitting ones, you know. Whenever you've got something that's like that's producing light, there's a cost associated with that. What I mean is, you know, entropy. You know, everything eventually dies. Everything, you know, goes into a disordered state. There's lots of coating or something on this. It stinks. You know, that plasticky sort of cheap manufacturing fiberglassy sort of smell. Yeah, that's what it is. It's a conformal coating or something, or the flux, I think, that was never properly cleaned off these at manufacture. But anyway, that'll do. I've had a bit of a clean around there. You can see there's some marks here. You can see it in the light. You see that? Yeah, it's got that like fiberglassy, plasticky sort of smell. And you could, while you're here, just get some contact glue into the buttons, but the buttons work perfectly on this. So yeah, we are all done. Let's simply reassemble it now. Let's just see if we can clip that switch back on. We can't, can we? Ugh, you just knew I'd have to take that back out again. And of course, it's one thing testing it without the lid on. As soon as you've got the lid on, any light that's coming out of that LED that's you know, being scattered could get scattered all over the place. You may find that both directions don't work now. Yeah, I'm talking from prior experience of messing with infrared LEDs. You've got to make sure you, like say, the heat shrink thing. You know, it's the heat shrink thing. Just make sure you stop light from going absolutely everywhere, or your mouse sensors inside get blinded and go, what on earth's going on? I've got so much light here, I don't know what to do. Before I forget, don't forget to clean your ball. Yeah, so I use a bit of IPA. People will tell you, don't use IPA, it disintegrates them. Well, it does on some mouse balls, but yeah, you tend to find that you get a feel for, you know, when you get one of these, you realise whether you can use IPA or not. You know, it's not dissolving it, it isn't. You know, I've cleaned all my mice that way over the years, never had a problem. When the balls disintegrate, they just disintegrate regardless of cleaning. E.g. some of the acorn mice are like that. The other thing is, oh, hang on, I've lost the ball now, it's wheeled off. Yeah, clean the rollers here, because then you'll get a smooth movement as well. And there's a tension wheel at the back there, so yeah, clean that one as well. So connected up and working perfectly. So yeah, I hope you found that little nugget of information helpful. Yeah, and just showing you here, you can go left and right, and up and down. I'll catch you in the next video.